Ready to scale your agent memory? In-memory storage is great for development, but production systems need something more robust. That's where Qdrant comes in, a production-grade vector database designed for exactly this use case. In this video, we'll cover what vector databases do, how to set up Qdrant, and how semantic search works at scale. Let's start with the basics. A vector database converts text into numerical vectors called embeddings. It stores millions of these vectors efficiently, and when you search, it finds similar content using math rather than keywords. This is perfect for agent memory because your agents can find relevant information even when the exact words don't match. Praval supports multiple backends. In-memory is fast but ephemeral. ChromaDB gives you local persistence with a file-based store. Qdrant is the production choice, offering performance, reliability, and the ability to handle millions of memories across distributed systems. When your agents need to remember a lot and remember reliably, Qdrant is the answer. Setting up Qdrant is surprisingly easy. One Docker command and you're running. Qdrant starts on port 6333, ready to store your vectors. In production, you'd obviously configure this more carefully, but for development and testing, this gets you going in seconds. To connect your agents to Qdrant, you pass a memory_config to your agent. Set the backend to Qdrant and provide the Qdrant_URL. That's the only configuration needed. Now when your agent calls remember or recall, the data flows to and from Qdrant automatically. Here's the full setup. We import the agent class and create an agent with memory_enabled set to true. Notice the comment reminding you to start Qdrant with Docker first. In the memory_config, we specify Qdrant as the backend and provide the URL. The agent now uses Qdrant for all its memory operations. Let me explain what happens under the hood. When you call remember, your text is converted to an embedding vector, basically a list of numbers that captures the meaning. That vector is stored in Qdrant. When you call recall, your query is also converted to a vector. Qdrant finds the closest vectors using similarity math and returns the matching memories. It's fast, and it works on meaning, not just keywords. Using Qdrant looks exactly like using in-memory storage. We call remember with our content, just like before. We're storing 3 facts here: who created Python, the coral reef metaphor, and how agents communicate. Each has an important score. The calls are identical to in-memory, but now everything is persisted to Qdrant and survives restarts. No more lost context between sessions. This is semantic search. We call recall with who made Python. Notice we said made, but we stored created. The vector similarity finds the right memory because the meaning is similar. We loop through results and print each match with its similarity score. Try searching how do agents talk, and it'll find the spore's content. You don't need exact keyword matches. Praval supports multiple embedding providers. Sentence Transformers runs locally and is completely free. OpenAI provides excellent quality if you have an API key. Cohere offers strong multilingual support. The default is Sentence Transformers, which works great for most use cases without any external dependencies. When should you use which backend? In memory for development, when you're iterating fast and don't need persistence. For small datasets where memories don't need to survive restarts. Use Qdrant for production systems, large knowledge bases, and anywhere memories must persist across application restarts. The configuration is simple, so there's no reason not to use Qdrant for anything serious. Let's wrap up. Vector databases store embeddings for fast similarity search. Qdrant is production-grade and scales to millions of memories. Configure it with backend set to Qdrant in your memory_config. Semantic search finds by meaning, not just keywords. And your data persists across restarts, so agents truly remember. In the final video, we'll cover production features, distributed agents, security, and observability. See you there.